Hi students, today we will see assignment model maximization problem. So the problem is the processing time in minutes taken by 5 operator to make a 5 different products are given below. The effective working hours in a day are 6 hours. So we will see the table. So here these are the operators, operator A, B, C, D, E and products 1, 2, 3, 4 and 5. So profit per products are, here you can see rupees 4, 2, 3, 3 and 4 for the product 1, 2, 3, 4 and 5. So I will write here for product 1, suppose the profit is of 4 rupees, then for 2, 2 rupees, then 3 rupees, 3 rupees and 4 rupees. So this is the profit and these are the operators. So first we will see the problem. So the matrix is given as the time required to complete the operation. So here you can see the processing time in minutes taken by 5 operators. So matrix is a time matrix, but we have to find out the maximize the total profit. So in the problem the matrix is given of a time matrix and final answer they want in a profit. So first we have to convert this time matrix into the profit matrix. So how we will convert, that we will see here. Okay. Now if you check here, the total effective working hours are 6 hours. So 6 hours means 60 minutes, okay, and in each hour and 60. So there is a 360 minutes available in the 6 hours. Now in the matrix you can see 10 minutes required for operator A to complete a product 1. So first we will calculate the product matrix. So how many products we can produce in a given time. So first we will prepare product matrix. So how we can prepare a product matrix. So for that 360 minutes is a total time available and for one product 10 minutes is required. So here we can 360 divided by 10. So that much product is produced by operator A. Similarly here 360 divided by 12, that much products are produced by the operator A for product number 2. So likewise we can produce the product matrix first and then we will calculate the profit matrix. So here I have prepared this product matrix. So for that here 360 minutes are available. You can see 360 minutes divided by 10. So total number of product produced are 36. So here I have prepared. Similarly 360 divided by 12. So 30 products are produced. 360 divided by 18, 20 products are produced. Similarly 360 by 15, 360 by 9. So this is actually product matrix. So we have calculated products, number of products produced in a given time, because we are having a 6 hours means 360 minutes. For each product 10 minutes are required. So from 360 minutes we can produce 36 products. So this is a product matrix. So first step is to find out the product matrix. Now here we have prepared this product matrix. Now we have to find out the total profit matrix. As in the problem it is given, so profit per products are 4 rupees, 2 rupees, 3 rupees, 3 rupees and 4 rupees respectively for 1, 2, 3, 4 and 5. So here I have written 4, 2, 3, 3, 4. So I will write here once again also. So profit is 4 rupees, then 2, then 3, then 3 and 4. So this is for product 1. So this column is for a product 1. This column is for a product 2. Here this is for 3, here this is for 4 and 5. Now we will prepare the profit matrix. Now how to prepare a profit matrix? Means 36 products are produced and in this each product having a 4 rupees profit. So 36 into 4. So that will be the total profit for operator A and product number 1. Similarly 30 into 4. Similarly 45 into 4. Similarly 40 into 4. Similarly 36 into 4. So that will be the next matrix we want to prepare here. So after multiplication of this. Similarly for product number 2 the profit is 2 rupees. So we can multiply this 30 into 2, 36 into 2, 40 into 2. Likewise we have to prepare for third product. Multiplying by 3 is a profit. Similarly for next 3 is a profit. Similarly for next 4 is a profit. So we can prepare a profit matrix. So here we can prepare profit matrix by multiplying the profit value given in the problem. So here we can multiply this. So here we get 36 into 4, that will be the 144, 30 into 4, that will be the 120. So you can see this is the answer after multiplication of the matrix. So here we can say this is a profit matrix. Now why we have found out this profit matrix? Because in the problem, if you check in the problem, they have asked maximize the total profit. So maximize the total profit, but in the problem the time required to complete each unit is given and total time available is 6 hours, that means 360 minutes. So first we have calculated the product matrix, how many products we can produce in a given time. So here we have calculated these 36, 30, 20, 24, these products we can produce in a given time. Now each product having its profit 4 rupees, 2, 3, 3 and 4. So we have multiplied that product by the number of products and then after that we will get this profit matrix. So here we got the profit matrix. Okay. Now assignment problem or assignment model or Hungarian model is used to only for a minimization problem. Okay. So this is a for a minimization problem, but our problem is a profit matrix and profit should be maximized. So we have to convert into minimization problem. So this is actually maximization problem because profit we want to maximize the profit. So this is maximize the profit. We want to convert that into the minimization problem. Now what is the step to convert the maximization problem into the minimization problem? We will see. So for that, in the matrix, find out the highest value. So if you check the matrix, so in this matrix 180 is the highest value. So here 180 and here is also 180. So that is the highest value. Where now how to convert this maximization into minimization? So we are subtracting all the values from that 180. So I will repeat once again the step how to convert this maximization problem. Why this problem is maximization? Because this is a profit matrix and always profit should be maximized. So we have to convert that maximization problem into minimization. For that we want to select the maximum value from the matrix. So here 180 is the maximum value and now we will subtract all the values from 180. So how? So here 180 minus 144, then here 180 minus 60, here 180 minus 60, 180 minus 72, 180 minus 160. Similarly here 180 minus 120, here 180 minus 180, 180 minus 160, 180 minus 144. So like that for all the matrix we have to do this procedure to convert into the minimization problem, because Hungarian method is used to solve the problem of a minimization problem. So after doing this subtraction we will get the matrix. So this is a matrix after the subtraction we will get. So if you see here 180 minus 144, that will be 60, 180 minus 120, that will be the 60 here, then 180 minus 180 is 0. So this is now we have converted problem into the minimization problem. Now this is a minimization problem and we can solve by the Hungarian method of assignment model. We can solve. Now we know what is the first step to solve the problem. So first step, that check the problem is balanced or not. So 5 rows and 5 columns are there, so problem is balanced. Then next step is a row subtraction. That step is a row subtraction. So what it comes in the row subtraction? In earlier video we have seen that we are selecting the smallest value. So from the row number 1, suppose we are selecting the smallest value. So in this 20 is the smallest value and we are subtracting this 20 from all the elements. So means 36 minus 20, 120 minus 20, 120 minus 20, 108 minus 20 and 20 minus 20. Similarly for the second row, smallest value is a 36. So we will subtract this 36 from all the element of that row. 60 minus 36, 108 minus 36, 120 minus 36. So similarly for the third row, in the third row 0 is the smallest value, in the fourth row 20 is the smallest value, and in the fifth row again you can check 36 is the smallest value. So after doing this subtraction we will get the matrix. So here you can see this matrix we will get after row subtraction. So 36 minus 20 you will get a 16, then 100, 100 and 88. Like that you will get the all the values after doing the row subtraction. After row subtraction, next step is a column subtraction. We know these are the steps. Next step is a column subtraction. So what we have to do in the column subtraction? So in the first column select the smallest value. So here smallest value is a 0 and subtract this value from all the elements. So 16 minus 0, 24 minus 0, 0 minus 0. Similarly, in the second column, select the smallest value. Now 70 is the smallest value in the second column. So select that 70 and subtract from all the values. 100 minus 70, 72 minus 70, 100 minus 70, 70 minus 70. Similarly, in the third column, 84 is the smallest value. In the fourth, 54 is the smallest, and in the fifth, 0 is the smallest. So after doing this subtraction, you will get this answer, that is a column subtraction. So 16 minus 0, 16, 24 minus 0, 24. In the second row, 100 minus 70, 30. So 72 minus 70 is a 2. So like that you will get the column subtraction. After column subtraction, so this is the matrix of a column subtraction. After column subtraction, so next step is making the assignment. As in the previous video, we have seen how to do the assignment. So making the assignment is the next step. So we'll see how to do. Now I will do in this matrix only assignment. So you check in the first row, if there is a 1 0, make the assignment here. So I am making the assignment or giving the assignment here. Then crossing out all the zeros in that row and in that column. So in that row there is no 0, but in the column there are 0. So we will cross this 0. Then coming to the next row, so there is no 0 left. Then coming to the third row, in this row, so here there is a 0. So we will give the assignment here and we will cross other zeros in that row and in that column. Then coming to the next column, so here there is 1 0 left. So we will make the assignment here and we will cross other 0, but there are no other zeros in that row and in that column. Then coming to the last row, so in the last row there are 2 zeros. So I will give the first 0 assignment and I will cross other 0. Now our final answer is a optimum when in each row and each column there is a assignment. That time in each row and each column, if there is assignment, then our answer is optimum answer. But in the second row there is a no assignment. That means we have to modify again the this matrix and we will solve with the further steps. So what is the further step? So I will do the operation in the same matrix, and if you are not aware of the procedure, then see the previous videos. So how to do the marking the row and marking the column step? So there is a procedure. Mark the row where there is a no assignment. So in the second row there is a no assignment, so I will mark the row. So mark the row where there is no assignment. Now in the marked row we are checking for the 0. So in this marked row, checking for the 0, that is, this is 0 which is already crossed. So we will mark that column. So we will mark this column. First step is mark the row where there is no assignment. In this row there is no assignment. Now in this marked row we are checking for 0. So here it is a 0 which is already crossed. Then we will mark that column. Now in the marked column we are checking for the assignment. So in the marked column, here this is assignment, so 0. So we will mark that row once again. Okay. Again in the marked row we are checking for other 0, but there is no other 0. So we will stop here and we will draw the lines from unmarked row and marked column. Unmarked row means where the row is not marked. So here check third row, fourth row and fifth row. So these rows are not marked. So we will draw the lines from unmarked row and marked column. Only one column is marked, so this column should be marked. Okay. Now what next step is, from the remaining value. So here you can see these are the remaining values: 16, 30, 16, 30, 34, 24, 2, 6 and 30. So these are the remaining value. So next step is, from this remaining value select the smallest element. So select the smallest element. So 2 is the smallest element from remaining value. We will subtract this 2 from other element, all the element of which is not covered by line. Means what? So we will subtract this 2 from 16. So 16 minus 2, 30 minus 2, 16 minus 2, 34 minus 2, 24 minus 2, 2 minus 2, 6 minus 2 and 30 minus 2. And we will add these 2 at the junction of a 2 line. At the junction means where these 2 lines meet. So here 2 line meets, so we will add 2 here. Here the 2 line meets means we will add 2 here, and here also we will add 2. And we have to prepare the next matrix or revise the matrix after this subtraction and addition, and all the values which are covered by the line, means these values remaining as it is, we have to only add at the junction, and the element which are not covered by the line we will subtract from that element. So I will repeat this matrix or prepare this matrix once again and write all the values here. Okay, so this is a 5 by 5 matrix, so I want to prepare this 5 by 5 matrix, 1 2 3 4 and 5. So I will prepare this 2 3 4, and once again I will write another. So this is 5 by 5 matrix, and I will write all the values after doing the revision matrix. So I will zoom out this, just a minute. Okay, so that will be better. Okay, now here what we have to do, so here 16 minus 2, that will be the 14, then 30 minus 2, that will be the 18, then 60 minus 2, that will be the 14, then 34 minus 2, 32. Similarly here it will be 22, then 2 minus 2, 0, 6 minus 2, that is 4, 30 minus 2, that is a 28. So I have done this operation which are not covered by the line, and we will add at junction, means here plus 2, 0 plus 2, so that will be 0 plus 2, that will be here becoming 2, then 40 plus 2, that is 42, and 0 plus 2, 2, and all the values remaining which are covered by the line remaining as it is. So I will write all the values remaining as it is. So here there is 0, here it is 0, here it is 0, 30, 24 and 18. Similarly here 0, 0, 31, 16, and in the last row 0, 26, 0 and 0. So we have revised the matrix. So here we can say this is a revised matrix. Now in the revised matrix, again we have to do the assignment or making the assignment. We have to repeat the procedure making the assignment. So I will repeat this procedure of making the assignment. So in the first row, there is 1 0, so we will give the assignment here, and we will cross other zeros in that row and in that column. So I have crossed in that column. Then come to the next row. So in the next row there is only 1 0, so we will make the assignment here and cross other zeros in that row and in that column. Similarly, coming to the third row, so here I will make the assignment and I will cross all the zeros in that row and in that column. Then coming to the fourth row, so there is a no zero left. Then coming to the fifth row, there are 2 0, so I will make the assignment here and I will cross this. Now our answer is optimum if there is in each row and each column there is a assignment. But if you check here, so in this, if you check here, in the first row there is assignment, second row assignment, in the third row assignment, but in the fourth row there is a no assignment. So again we have to repeat the same procedure. So I will repeat the same procedure. I will use the another color. So okay, so here mark the row. What is the procedure? Mark the row where there is a no assignment. So in the fourth row there is a no assignment, so I will mark the row where there is no assignment. Now in the marked row we have to check for the 0. So in the this marked row, checking for the 0, so here it is 0 and here it is 0. So at two locations there is 0, so we will mark that column. So in the marked row, checking for the 0, and in where there is 0 we will mark that column. Now in the marked column we are looking for the assignment. So in this column here it is assignment. So in the first column here it is assignment, so we will mark that row, and in the second column here is the assignment, so we will mark that row also. Okay, again we have to check for the assignment. So in this row where there is any other 0, so in this row if there is any other 0, so here it is a 0, so again we have to mark that column. Again we will check for a second row, so here we have crossed this row, so there is no 0 left, here is no 0 left, so we have marked this column. Again we have to check in this marked column any other assignment is there. So in this column here there is an assignment, so we will mark again that row. Okay, now again check in that row if there is any other 0 left. So in this row if there is no 0 left, so we will stop here. So once again I will revise this procedure. What is the procedure? So mark the row where there is an assignment. So first step is mark the row where there is a no assignment. Sorry, there is a no assignment. Then after that check for a 0. The next step is check for 0. If found 0, then mark that column. If you found the 0, then mark that column. If you mark that column, again in that column check for assignment. Then check for assignment, and if there is assignment, then mark the row and repeat this procedure again. So we have done this procedure, and we have to draw the lines from unmarked row and marked column. So unmarked row, so first 4 rows are marked, so last row is remaining. So unmarked row I will draw this, and then marked column. So I will mark this first column, then second, and this column also. Now again we have to do the same procedure. The lines which are not covered by the line, so here 14, 32, 4, 28, 24, 18, 31 and 16. So these elements are not covered by line. So from these elements we have to select the smallest element. So 4 is the smallest element here. So 4 is smallest. So we have to subtract this 4. So 14 minus 4, 32 minus 4, 4 minus 4, 24 minus 4, 24 minus 4, 18 minus 4, 31 minus 4, 16 minus 4, and we have to add at the junction. Junction means where two line meets. So here it meets, so we will add 4 here, here, and at this location, because there is intersection of a line. Again we have to revise this matrix. So I will once again I will prepare this 5 by 5 matrix, and in that I will put all the values. Once again I will zoom out this for better viewing. So here 5 by 5 matrix we have to prepare 1, 2, 3, 4 and 5. Similarly there are 5 rows. So 5 rows, and I will write the values here. So first I will write the unoccupied cell. So here 14 minus 4 means in the third column, so that will be the 10. 32 minus 4, that will be the 28. 4 minus 4 0, 28 minus 4, that is 24. Then 24 minus 4 20, 18 minus 4 14, 31 minus 4 27, and 16 minus 4 12, and added at junction. So here 0 plus 4, that will be 4, 26 plus 4 30, and here 2 plus 4 6, and all the remaining value we will write as it is. So here there is a 14, then 22, then 0, then 0, again 28, 0, 30, 0. Similarly here it is 0, here it is 0. So you can see from a previous matrix and write all the values as it is. Now here we have done this is second revised matrix, and here this is a revised matrix. Now next step is to making the assignment. So I will do the assignment in this matrix only. So first we have to give the assignment. In the first row check for the 0. So here only one 0. So we will make the assignment here and cross all the zeros in that row and in that column. Then coming to the second row, so there are 2 zeros, so we will skip that zeros, because first we are giving the assignment to the only 1 0. Then coming to the third row, so there is a 1 0, we will make the assignment here and cross all the zeros in that row and in that column. Then coming to the fourth row, so here there is 1 0 left, so we will make the assignment here and cross all the zeros in that row and in that column. So in the column there is 0 at this location, so we will cross this 0. Then coming to the fifth row, so there are 2 0, again we will skip here these 2 zeros because there are 2 0. We will go back to the again first row. In the first row there is assignment made. In the second row there is only 1 0 left, so we will make the assignment here and cross other zeros in that column. Then coming back to the fifth row, here only 1 0 is left, so we will make the assignment here. So this is in each row and each column, so there is an assignment. So this is our final answer. Now here we know these are the operators. Here you can say A, B, C, D and E. These are the operators, and these are the products 1, 2, 3, 4 and 5. So A operator is assigned for product number 5, then B to the 3, C to the 1, then D to the 2 and E to the 4. So this is a final assignment, but here we have to find out the maximization of profit. So we know we have calculated the profit matrix in the previous cases. So here this is a profit matrix we have calculated. So I have copied this profit matrix here. So this is a profit matrix. Then A is assigned to the 5. So A is assigned to the 5. So this value. So 160 is the profit. Then B to the 3. So 54 is there. Then C to the 1. So 180 is the profit. Then D to the 2. 90 is the profit. And E to the 4. So here 90 is the profit. If you make the addition of this, so you will get the answer is 574. So this is actually total profit after solving the problem. This is the final answer of this problem. Thank you.